Ich gehe jetzt nicht nochmal raus. Please come in, please. I think they hear this. Yeah, I heard when I was out, I heard other people speaking.
But it's not loud enough outside.
Yeah, maybe.
They hear it, but they don't hear it well.
Ja, also ich gehe nicht nochmal raus. Es ist mir zu blöd.
Ja.
Please bring the people in. Please try to find your seat. We are late already. Please, please.
La presentación tiene que estar aquí porque eso es lo general. Día 2. Este. Peter Schad, este. Sí. Okay.
Next.
Yeah.
You
Okay.
will not want to be told all the things which will happen in the future, but it's for self-classification people, it's very important to hear what's going on in WRB. And we are also allowed to ask questions, because this will be taken in the discussion which is following. Now, Peter, please start with your presentation.
Yeah, thank you, Carl. Can you hear me like that? Yes?
Yeah.
Okay. So we are on the way to the 4th edition of the WRB to be presented this year in Glasgow. And many of you have received the draft, which I sent around January 31st. Of course, there have been some changes in the draft. In some days, hopefully I will send a second draft, at least to the members of the WRB board. Okay, let's do a few words about history. The first edition was in 1998 with 30 reference all groups. Then 2006, 2 more, the second edition with 32. And this second edition was not suitable to use for mapping. Therefore, in 2010, guidelines for constructing small-scale map legends using the WRB were published. And 2014, with an update 2015, the third edition was published, same number of reference hall groups. And now the idea to serve both, classifying, naming individual soil profiles, and also using WRB as a tool for creating map legends. Yes, this is the current WRB. So the editor is the ISS working group WRB, and the chair team was myself, Conny van Huisteen, and Erika Micheli. And it was in that time published by FAO in the series of World Soil Resources reports. We have a WRB homepage. This is at our institute. And the document you can download from the FAO. And there are 2 apps with Android and Windows. And there are many translations: Spanish, French, Russian, Polish, Georgian, Slovene, and Czech. Maybe I have to do it that way. Okay, so some history. The progress made in 2014, one major progress was the redistribution of qualifiers. So in 2006, we had prefix and suffix qualifiers. The prefix were 2 groups, typically associated qualifiers and integrates. And all the others were suffix qualifiers, among them some very important one, and among the typically associated ones, some of really minor importance. And it was possible to name soils, but impossible to make map legends, because for map legends you need the most important ones, and some were hidden as the suffix qualifiers and some non-important ones in the typically associated ones. Now 2014, we have the principal qualifiers ranked according to importance. Of course, there may be some disagreement. What is important? I say this is important, you say that is important, but I think we more or less got to an agreement. And the rest is the supplementary qualifiers, which are alphabetical. And with that, it is possible to name soils and to make map legends. So how to proceed from, well, map showing soils in the landscape to a map unit? The first step is ignore the soils that cover small areas. That's why we have the dominant soils that cover at least 50% of the area of the map unit, the codominant soils 25 to 50, the associated soils 5 to 35, and the rest is ignored. Doesn't show up in the name of the map unit. And the second step is reduce the number of qualifiers. So the first scale level is just the reference soil group, the second with the first applying principal qualifier, the third with the first 2 applying principal qualifiers, and the fourth scale level with the first 3 applying principal qualifiers. And if you are thinking that an important characteristic for your map unit is missing, then you have the possibilities, you have the right to add after the name of the reference soil group other qualifiers that may be added optionally, which may principal, not yet in the name, or may supplementary, and they may be added at any scale level, first, second, third, or fourth. Another progress, I think, is the introduction of the sub-qualifiers. Skeletic, for instance, is a qualifier, endo is a specifier, and endoskeletic is the sub-qualifier. We have sub-qualifiers with a given definition, and like proto-calcic, and we have sub-qualifiers constructed by the user. Some are related to depth requirements, others to other requirements. And we have, amongst these sub-qualifiers, optional, additional, and mandatory ones. The mandatory sub-qualifiers, this is a small number. All the others are optional, additional. That means it's your decision whether you use them or not. Other progresses of 2014, introduction of a new chapter, rules for naming soils and creating legends for soil maps. This chapter is very important and very helpful, but only if you read it. So it's just 9 pages. And on the reference soil group level, there was one change made. Albuluvial soils were deleted, ready soils introduced. Albuluvial soils had a so specific definition that they hardly existed. And of course, many definitions, I think, better worded. Okay, the demand of a new edition. Is there a demand from the community? Before 2014, based on the 2006 version, yes, there was a strong demand from the community, especially because the 2006 version was unsuitable for making maps. And before 2022, I do not really realize that this community doesn't request a new edition. The community seems to be more or less happy. Of course, some improvements can be made, some things maybe not so good, but generally the community seems to be happy. What about the inner WRB circle? So people like you. We made from 2014 to 2019 common excursions. And one of the insights is always we fight about what we see, which characteristics are present in soil. And if we agree, after agreement, classification goes fluent. So many field terms in the WRB criteria are nowhere precisely defined. Not in the FAO guidelines, which have been recommended to use, and not in the WRB itself. And if we do soil description according to the FAO guidelines, some field criteria are not provided at all. And some others are provided, but not the needed limit values. So you cannot really use them. So we have not really a field guide. And the second thing we experienced, we developed an automated classification. This was done by Einar Eberhard and myself. And the input data we used, input field data, are according to the German field guide. And the input lab data, of course, are general. We published that in 2019. It works quite well if we have complete data. But some criteria are almost impossible to automatize. And some criteria are so specific that they are normally not surveyed in the field. So if we look at the field descriptions, we don't find what we need. So they are not described in any field guide, neither FAO guidelines nor somewhere else. You must have in mind, okay, I will need some specific criteria here. You must know that in advance and then especially look for that, but you will never find it in your databases. So that's why we made the decision to develop a new field guide and give it as an annex to the WRB. Okay. This new field guide provides precise definitions of field characteristics and guarantees the survey of all the field characteristics needed for the WRB definitions. It provides something more, but not much more. So if you are interested in other things, you may need other guides. And it provides quantitative field data where required for WRB. And we have the advantage all in one book, the classification and the field description. So they are really related to each other. All in one book, that's how the book should look like. 7 chapters. The first is always the introduction. You may skip background and basics. The second is very important. You must read it, the rules for naming soils and creating legends for soil maps. Then third, as it was before, diagnostic horizons, properties and materials. For key to the reference soil groups is list of principal and supplementary qualifiers, definition of qualifiers. So no change in the sequence of chapters up to now, but now the codes for reference soil groups, qualifiers and specifiers were an annex up till now. They will be a chapter in the next WRB because these codes are mandatory. If you use codes, you must use these ones. You're not obliged to use codes, but if so, use these ones. That's why they belong to the main text and then the references. And annexes, Annex 1, the field guide. This is new, replacing the FAO guidelines. Annex 2, summary of analytical procedures for soil characterization. This is as before, with some updates, of course. Annex 3, horizon and layer designations. This is also new, replacing also the FAO guidelines. 4 is a soil description sheet. This is also new, and it's an Excel file. So it's not printed. It's an Excel file, and I will explain it later. Annex 5, color symbols for reference soil group maps. Just a suggestion, because I got many questions, requests. Which colors should I use? Okay. Coincidence of main text and field guide. Example with texture. We have the problem different countries have different particle size classes. Especially there is no agreement where is the limit between sand and silt. WRB has it and ISO has it at 63 micrometers, United States and many other countries at 50 micrometers, Australia at 20 micrometers, Russia has a different system. So this is will cause many problems if we use words like silt and don't know according to which system we use it. Also, different countries have different texture classes. And therefore, also different countries have different guides for hand texturing. This is what we have in WRB, in FAO, and in the United States. The United States designed it. This is England. You see, same names, but different areas in the triangle. And this is Australia. Again, different areas in the triangle. So if you do hand texturing, you will get different results. What you call silt loam, others may call clay loam, and so on. That's why we developed, based on especially 2 documents, one from the United States and one from England, our own flowchart for hand texturing, leading to the 12 texture classes we have. And this is a triangle where you see in 4 colors where the 4 qualifiers of WRB are found. Yeah, next example for this coincidence, the structure. For instance, Titelic Horizon 2015, criterion 3, has moderate to strong blocky structure, breaking into polyhedral or flat-edged or nut-shaped elements. Looking at the FAO guidelines, there is no polyhedral, no flat-edged, no nut-shaped structure. Titelic Horizon 2022, more or less the same wording, just I systematized and harmonized the wordings in all the diagnostics and in the field guide. So has moderate to strong blocky structure, breaking into polyhedral or flat-edged or nut-shaped second-level structure. And now we have this definition in our Annex 1. And you see here the pictures. So we designed pictures for all the structures together with explanations. Other example, redoxomorphic features. Look at the technical properties 2015. Mottles and or concretions and on nodules, the color of which is considered to be oxymorphic, that are, if soil aggregates are present, predominantly inside the aggregates and have moist amansal color U 2.5 units, at least 2.5 units redder than the surrounding material, and amansal color chroma at least 1 unit higher than the surrounding material. If we do soil survey with the FAO guidelines, what do we get? Mottling, we get color, abundance, class, size, contrast bound, and boundary. These are the tables 35 to 32 to 35, but no location, which is crucial for distinguishing Stucknick and Golake properties. And the concretions and nodules, they have no muzzle color. And what is also not questioned to have a decision or an idea whether it's oxymorphic or other. And then the key to the reference oil groups requires Stucknick properties in which the area of reductimorphic colors plus the area of oxymorphic colors is at least 50% of the layer's total area. But we have abundance classes. How to calculate a percentage from abundance classes. This is all changed now. Stucknick properties criterion 2 sounds familiar. The oxymorphic features are if soil aggregates are present predominantly inside the aggregates and have, compared against the matrix color, the following munsell colors: moist, a hue at least 2.5 units redder, and a chroma at least 1 unit higher. So we get that from the Annex 1. Color, and for each color separately, you have to detect the substance. This is required for all oxymorphic features and for some reductimorphic features. The location for both all oxymorphic and reductimorphic features. The size only for oxymorphic features inside aggregates. The cementation only for oxymorphic features. And the abundance, that's now by percent. So oxymorphic and reductimorphic features, you can establish, observe the percent. And then we can decide for the key Stucknick properties in which the area of reductimorphic features plus the area of oxymorphic features is at least 1/3 weighted average. So with this combination of field guide and definitions in the main text, we can come to a conclusion. We took many of the definitions from the NRS field guide, field book. I had a meeting with Curtis Mongra in 2019 when we discussed that, and he allowed me to do that. And many definitions are from there. Some literally, most are modified because the criteria of the field, they are not independent from the classification system. So you cannot copy them one by one, but they are very close. And of course, having common or at least similar, very similar definitions of field characteristics, this brings both systems closer together. So we talk about the same things. Annex 2. Now that's all I have in my presentation about Annex 1. Let's go to Annex 2. Summary of analytical procedures for soil characterization. We had that already in 2015, and it's a little bit updated. And what I especially added, pH alternatives if base saturation or relationships between cations are not available. So we can use the pH, but it's defined now which, and depending on what, depending, for instance, on organic matter. Annex 3 is horizon and layer designations. We have master symbols and suffixes to replace what is in the FAO guidelines. And now these are, of course, based on field characteristics, but also on lab characteristics, at least some of them. You need for your decision a lab characteristic. And of course, these are only rough descriptions, not intended to be definitions as in the diagnostics. That's not a second soil classification system. Okay, and here I put something in red. I know that some soil scientists do the following. They see a profile and say, oh, this is this soil, for instance, a stagnant soil. Then they give names, give symbols to the soil horizons to make sure that the soil is a stagnant soil. And after that, they describe the horizons to make sure that the characteristics fit the horizon designations. How can we prevent our colleagues, or I even must say that I'm not completely unguilty, not completely innocent when I describe a profile. What can we do to minimize this risk, my suggestion is place the horizon designations somewhere further behind in the book, after that require or force people to do the description first, to start with that. This also fits to what Curtis said in his interesting presentation. So we have to start with the morphology, and all other classification and genesis is deduced based on what we have seen. We come into some problems. We used up the lowercase letters for suffixes. All the alphabet is already used up. Some even twice, with different meanings for organic and mineral horizons. That's not a problem, but we cannot have two different meanings for within the group of mineral horizons. So what can we do if we want to express new characteristics? Introduce Greek or Cyrillic characters? Or introduce special characters? We already have the at for the cryogenic alteration. So we can introduce, for instance, the paragraph for human transported material. Human transported material, artifacts we already have. This is the U. I heard from John that you suggest a caret. I don't like that, because I think a symbol should start at the baseline and not be somewhat further up. Maybe we can also agree on using a symbol for the human transported material. And I think we need a symbol for layers with volcanic classes. If it's a lowercase symbol, for instance, this and or whatever. We could also, for volcanic classes, we could also have the option to use a master capital letter, and then which we can then combine with other capital letters. So this is not so much the problem, but for human transported material, we really need a lowercase symbol. Okay, now about the profile description sheet. It's an Excel file with 2 parts, general data and layer descriptions, and 3 levels. So we provide macros. Complete, which is very large, of course, intermediate, and minimal. But we also invite you to create your individual Excel file and delete what you not need or maybe not want. Not really force that you don't want something, but many things you really don't need. So desert features, if you are not in the desert, there is no need to have them in your Excel file. Or climate and ecozone, if your country lies just in one, you don't need that. You don't have to report it all the time. And whatever you are sure you really don't need. And it looks like that. This is the general data. Okay, I just criticized that letters are too small in some presentations. Here they are too small, but you get an impression what it is. And brown, the field guide provides a code. And green, you have to add a figure or a name. And the same thing for the layer descriptions. Okay, and this is the last annex, Annex 5, color symbols for reference soil groups. These are more or less the colors of the atlases of the Joint Research Center of the European Commission. Up till now, we have it in red, green, and blue, and maybe we can also get from the JRC the CYMK system. Okay, now let's go to the general rules. So one problem is about soil surface and mineral soil surface, because we use these terms in WRB and they are nowhere defined. Look at this picture. Which soil do we have? There is some organic layer at the topsoil, and this is a trunk, thicker than 40 centimeters. And, well, where the trunk is, there's a folic histosol, because it has an organic layer thicker than 40 centimeters. And the rest is a cambisol. That doesn't look well. Other problem. This is, in West Siberia, an ombric histosol. And we have dead sphagnum residues in contact with living sphagnum plants. You see them on the right-hand side. The topsoil, there are living sphagnum, and the dead sphagnum parts in this further down are still connected. Where is the soil surface? Also here, problem 3. This is a soil after litter fall. You see there is a rather thick organic layer at the top. And this is in late summer. There's almost nothing. Litter layer thickness varies with season. That's why we thought about a definition of soil surface and introduce a litter layer. A litter layer is a layer that contains more than 90% by volume recognizable plant tissue, like this trunk. And that plant material still connected in to living plants, for instance, that parts of sphagnum mosses, is not regarded to be part of litter layer, only just what is really lying on the surface. And now we can define the soil surface, 0 centimeters, is the surface of the soil after removing, if present, the litter layer, and if present, below a layer of living plants, just the living plants, not the dead parts connected to them. And then the mineral soil surface, that's not so complicated, is the upper limit of the uppermost mineral horizon. Are we, with that, in agreement with other systems? See soil taxonomy. Conventionally, the soil surface is considered to be the top boundary of the first layer that can support plant growth or root growth. This equals to, let me jump to B, for vegetated mantles, for vegetated mineral soil, the upper boundary of the first layer that can support root growth, and C, for organic mantles, the same as B, but excludes freshly fallen plant litter and includes litter that has compacted and begun to decompose. This is the OI horizon in the US system. So it excludes freshly fallen plant litter and includes litter that has compacted and begun to decompose. And allow me to have a look to the German system. We look at the Bodenoberfläche, BOF. This is the upper limit of the uppermost horizon, including freshly fallen plant litter, which will be called OL horizon in the revision of the German system. So now we have solutions. This is solution 1. This is the soil surface. The trunk is just a litter layer. And the whole soil is a combi soil. Where is the soil surface here? Right below the green parts of sphagnum. And here, yes, it excludes the fresh fallen litter. So soil surface doesn't change with the seasons. So these are some general things, and now let's have a look at the reference soil groups and then some qualifiers. Reference soil group. I suggest a change in the sequence, planosols and stagnosols before nitisols and feral sols. This is suggested from Brazil, and I guess they have many experience with these soils. And I think it's very understandable. There is no suggestion for a new reference soil group, and there's a discussion, should we abolish retisols? So in the moment, the discussion is almost equal weighted. Both sides are almost equally strong. Are the retisols ecologically important? I think yes, because the coarser textured parts are the preferential water flow, and most roots are found there, not in the clay or richer part where they could have more to eat. Are they genetically important? Not so much. Can they easily be recognized, especially over large areas? No, simply no. And alternative make the definition stronger. For instance, require a higher minimum thickness of the layer with retic properties. This is a discussion where I really don't see what will be the decision. We will wait. We have to wait. Now let's see at some diagnostics. We have some abolitions. The Fulvic and Melanic horizons. These are more or less the direct result of vegetation, grassland versus forest. And they are only foreseen for undersoils, but they have don't provide a meaningful differentiation and could also occur in other reference soil groups. And they are based on the old idea that fulvic and humic acids exist, which is strongly questioned by the experts of organic matter. The other one to delete is the Jervik properties. This is an unsuitable combination of delta pH value, so delta pH 0 or even positive, and a very low cation exchange capacity. So we need three qualifiers: the POSIC for positive or 0 delta pH only, the VETIC for the very low CEC only, and the Jervik for a combination of both. Better have only two qualifiers: POSIC for the high delta pH, Jervik for the very low CEC, so we can delete the VETIC qualifiers and the Jervik properties. And now we have some news diagnostics in discussion. Here is the cohesive horizon, from Latin cohere, to stick together. This is a subsurface horizon with a massive structure or a weak soil aggregate structure. It's not cemented. Clay fraction is dominated by kaolinite, typical for old landscapes in the tropics with seasonal climate. And they are found in the national classification systems that have of countries with large areas in this ecozone. For instance, the Candosols in Australia. In South Africa, we have the apedal B horizon, and in Brazil, we have the Carata Coesu. This is, we can say, the counterpart of the Nitic horizon, which is strongly aggregated, and the cohesive almost not. And this, of course, has a significant negative impact on plant growth. Now, the Pan-Pike horizon. The question or the problem is starting with a Sombric horizon. What is a Sombric horizon? Is it a buried A horizon? Or is it the lower remnant of a formerly thicker topsoil A horizon? So developed under a climate that allows the development of thick A horizon. And then this climate changes, and the recent A horizon, the recent climate allows only the development of thin A horizon, and further down the organic material starts to decompose. But of course, if it's even further down, decomposition is slow, so there are still remnants of an A horizon. Is this the Sombric horizon, or is it a buried horizon? And this is an experience of mine I have since a long time. If I send a message to the community and ask for the discussion, nothing happens. If I set up a definition, and this new diagnostic horizon appears in the WRB, then people start research projects about that, and then we can come to an answer. That's why I suggest to introduce the Pan-Pike horizon, from Quechua Pan-Pai to Berry, for a buried A horizon. So we started already in 2014, not derive everything from Latin and Greek, but also give the opportunity to other languages worldwide to be reflected in WRB. And here, Quechua, the language spoken by the descendants of the Inca Empire. And now we can clearly say, if we have the Pan-Pike horizon, we can add to the definition of Sombric horizon no lithic discontinuity at its upper limit. So now it's a different thing, and then the research will start to prove that it exists or that it does not. This is the Titelic Horizon. From Georgian Titeli, which means red. Lateral accumulation of iron. So we have, it's usually found on lower slopes or in these depressions, and we have stagnosols or planosols upslope, and in inclined positions, it moved the reduced iron from this stagnosols and planosol, moves down by lateral subsurface water flow, and further down, the reduced iron gets in contact with oxygen, is oxidized and accumulates in a subsurface horizon, but close to the surface. So it is rich in oxide extractable iron, which gives the Titelic horizon a reddish color, we must find out a bit which color really it has. And if fine textured, a low bulk density. So I realized now that this is not the case and cannot be the case on coarser textured soils. So we will change this into an adequate definition of the Titelic horizon. Here, the issue with anthropogenic horizons. The current definitions make many of them mutually exclusive, which does not reflect the reality. See this example. From 0 to 20 centimeters, a horizon meets the criteria of the Hortic horizon. And from 20 to 50, the criteria of the Pretic horizon. Then it's not an anthrosol. Because the Pretic horizon is worded in such a way that it's exclusive to the Hortic horizon. And the anthrosol needs an anthropogenic horizon of at least 50 centimeters thickness. So this beautiful anthrosol will not key out as an anthrosol. Therefore, solution, take out this criteria from the Pretic horizon that makes it mutually exclusive from the Hortic. And now we have the Hortic horizon from 0 to 20 centimeters and the Pretic horizon from 0 to 50 centimeters, 20 centimeters coinciding with Hortic, and then this soil is an anthrosol. The issue of the petro horizons. Petrocalcic, petroduric, petrogypsic, petroplintic. So we had the discussion about the petrogypsic, you remember, in the excursion. All horizons need to be continuously cemented. They may have fractures. This is also part of the definition. But besides these fractures, they are continuously cemented. And to test that, look at the field guide, Annex 1. Specimens do not completely disintegrate in the water. And the cementation class of everyone is different. Petrogypsic only needs at least extremely weakly cemented, and petroduric weakly cemented, petrocalcic moderately, and petroplintic strongly, besides many other criteria every horizon has. So with these clear definitions in the field guide, we can easily detect all these petro horizons. And I propose a new diagnostic horizon. In the beginning, I called it petroclaic, but I got the solution that we could, the input that we also could call it limonitic, maybe a bit more adequate because it is cemented, but not necessarily continuously, and therefore it may be wise not to call it petro something. It develops in layers with clayic properties and oxymorphic features, and cementation class for those parts that are cemented at least moderately. Yeah, so the definitions CNRSS and RCS Fieldbook and WRB Annex 1, the same. Then new diagnostic material, we already discussed it yesterday when Sergey, oh, he left, Sergey pointed out that the Titelic horizon should not be a remnant of a former organic layer. The mulmic material from German Mulm, powdery detritus, mineral material derived from organic material. So if water-saturated organic material is drained, mostly artificially, a fast decomposition starts. While the amount of mineral components remains constant, where could they go? The amount of organic matter decreases by decomposition, and the organic matter content eventually falls below 20%, and then by definition, we have a mineral material. And this is useful as such. We can add the mulmic qualifier, but also the mulmic material can be used in many definitions. The histic qualifier, that it's still histic if we have waterlogged organic material, but the top is by drainage dried out and now no more organic. Or also for the mineralic qualifier, which we have in histosols when we have a sequence of organic and mineral layers in the histosols. And now the question raised yesterday, should we add to the criteria of the Titelic horizon not consisting of mulmic material? I think we should not add it to the molic horizon, but to the Titelic maybe. Yeah, and also new diagnostic material, organotechnic material, mainly to avoid the following problem. Organic material has to have at least 20% soil organic carbon. And soil organic carbon is a diagnostic material defined as organic carbon that does not meet the criteria of artifacts. This is very fine. It helps us easily in all the definitions, but up till now, all other materials are mineral material, even if they are 100% consisting of organic artifacts. We call them mineral material. And this doesn't sound good. That's why I have the idea to introduce the organotechnic material that has less than 20% soil organic carbon. So if it has more, then it's organic material, of course. Less, but it has, and this could go by volume, at least 35% artifacts that contain at least 20% organic carbon. With that, we can go to this organic technical material, organotechnic material, and avoid that a thing that is organic is called mineral. One sheet about the qualifiers, some new qualifiers, some others deleted. I checked all qualifiers. That was really not easy. Whether the depth criteria should be related to the soil surface or to the mineral soil surface. For some it's easy, for others not. Remaining problem, hyperskeletic must be related to the soil surface and skeletic to the mineral soil surface. Maybe we should replace the word hyperskeletic by something else. And another problem that remained, the calcic horizon. In mineral material, it must be related to the mineral soil surface. This is the calcic qualifier. But in organic material, for instance, in histosols, it must be related to the soil surface. We can have these accumulations of secondary carbonates in the organic material. And looking for a word, I looked up in the dictionary what it means is Polish for lime, and I suggest the Wapnick qualifier. If the Polish native speakers think that this doesn't sound good, we can choose another word. And we have up to now the acric, lixic, alic, and luvic qualifiers. And it may happen that we clearly see an Arctic horizon, but we don't know the cation exchange capacity and don't know the base saturation, and then we have to guess what it is. I don't like that. We can delete them, these four, and replace them by the Arctic qualifier. If we know the low CEC, we can anyway add the Titelic qualifier. This is a CEC below 24 cm per kilogram clay, like in the lixic and acric. And if we know the low base, the base status, we can indicate that with the district and the Utic qualifier. Nothing is lost. It's just a bit separated. What is our time frame? There's a WRB board with 15 soil scientists. Some are here in the room. We have several video meetings in the next weeks, and then we have an in-person meeting in Germany from May 31 to June 4 at my university. June 5, we all fly to Iceland. WRB this time will be an electronic publication only, but with an ISBN bought by the IUSS, and we will present it at the World Congress of Soil Science in Glasgow, July 31 to August 4. And now about the translations. I have up till now volunteers for translation into French, into Italian, and into Spanish. They are here. The one group for Spanish translation is from the INEGI, and the other is Carmen. Not here. Okay. Yes, thank you. And the most problematic of these three, of course, is Spanish. French, what is French? This is decided in France. What is Italian is decided in Italy. What is Spanish is decided in Spain, Mexico, Guatemala, El Salvador, Nicaragua, Argentina, and so on. So this is an important issue. American and European, so provide a draft and then sit together to decide on the keywords or use the same keywords as we had in 2015, that every Spanish-speaking nation can agree on that document. I'm sure there will be some translations in Other languages, like in WRB 2014, Polish, were the first ones. Yeah, and the last slide is just personal, because Wolfgang Zech, myself, and Gerd Hintermeyer-Erhardt made this book. You see the cover is already ready, and we think that it might be available in May or June. The soil is a plinter soil, as you see. And with this picture, thank you very much for your attention.
Okay, we heard a lot of details, but I would like to ask you first to ask the general questions, if you have any. Where are the great soil scientists to have general questions? There's so many details. Huh? If we start to ask if a calcic horizon can occur in a peaty soil, it is possible. And I'm not sure if this would be related to the top of a mineral soil. It's not existing. Huh?
Related?
It's not existing, calcic horizon. There's no mineral surface existing in a peat soil.
No mineral surface existing.
So there is coming up the general question. Curtis, come along.
I think this is a general question, but the soil surface versus the mineral soil surface. The soil surface, one forest fire and it's gone. One fire and that O horizon is gone. So it can be very ephemeral. It can be very dynamic. It can disappear rapidly. Is that a concern?
Yes, this is a concern. For the mineral soil surface, of course, will not change. The soil surface, including the organic layers, will change, will disappear, yes. Even if we exclude the litter layer, the others also can disappear. Do you have a suggestion for the solution?
At one time, in the UF system, the top of the soil was the top of the O horizon, and it would be the horizons would be measured down vertically. But because of forest fires and because the O horizon can be so, it can disappear so rapidly, it was moved down. And I think on our field trip, our field excursion, if you noticed, all of the tapes began at the mineral soil surface, and the organic was additional above
Counted
that.
upwards, yes.
Yeah. So that was why I was wondering if it is a concern.
Yeah. Okay, thank you.
Okay, now for the really, you have a general question? Go ahead. No, let's just start with the detail. Okay.
It is partly general, but it is, I think, also very detailed question, and I think it is never-ending discussion, as Peter said, and also Curtis. The distinction where is soil surface is absolutely crucial for classification of various soils. When we have, for example, continuous transition between litter, transformed litter, something what is hydrous, like peat litter, and to peat, and where is which thickness should be calculated as organic, how cold is organic. But the other problem for me is also important. That classification of organic horizons and naming of or letters, designations for organic horizons are already exactly the same for forest or meadow litters and for pits, for example, and the materials developed from pits. But in my opinion, it is not exactly the same concept and not exactly the same criteria. As you showed us, for example, classification of sub-horizons in Germany, OL, OF, OH, in my opinion, it is not exactly the same what we have for pits or E, and so on. And this is the reason for many troubles, in my opinion. Disagreements between WRB and local classifications. Additional problem is that in many countries also the classification of letters are different. Yes, the letters are also different use and different, how to say, definitions. As recently, for example, proposed by Zanella and other, it is completely a different story. Yes, but for me. The zero is where zero is very important, and as you told, we should probably exclude the fresh truffle because it is unstable, and we agree to this. But there is the tiled question to the limits, yes? Because if we put of 90% of preserved visible plant tissues, what's that? Is it all F or L? What's that? And or E or A, and people will have large troubles. So I agree with general idea to reject this fresh truffle, but better is the definition, the German definition, than 90%. So better is German, that we should just exclude OL or LL in some classifications, fresh truffle, without this 90%. Because 90%, what is 90% of visible tissues?
Okay, so first of all, the German OL is defined by having more than 90% visible plant tissue. This is exactly the same, and the 90% value is also in soil taxonomy. And I think if we have other limits like 1/2/3 and 1/6, and if you are able to determine 1/6 and 2/3, you're also able to determine 90%. We have the different capital letters, O and H. This is different to soil taxonomy that has only O. And with that, we make this differentiation. The other thing is, should we use different lowercase letters with different limit values? This has, of course, the advantage that we can do it more specifically, but it has the disadvantage that we made the system more complicated. People have to think in more, and I really think we have to be strong and do that only if we really are convinced that it's absolutely needed.
May I add, it's not so easy, Cesare, because we had this example where the litter disappears in a few months. I can show you soils where we have 7 litter layers. So the litter stays 7 years in this until is degraded to O horizon. Yeah. So in this case, you will always describe a litter layer.
I wanted just only to say that 90% of preserved visible plant tissues do not represent fresh truffle. Because in many OF horizons, we still have more than 90% of preserved. Maybe there are cutted, there are smaller, partly transformed, but still we have 95, 98% of preserved, recognizable plant tissues. Yes, so this is my suggestion, that 90% do not plus the border between OL and OF, but in many liters, somewhere in OF horizon. And this percentage will complicate us, not help, but in many situations may complicate establishing zero. Yeah.
So let me ask if I got it right. Your suggestion is leave out the percentage and just say it's fresh. Both soil taxonomy and German have these 90% value, and we use it since decades and didn't find the problem. But okay, now I got what you want, understood what you want.
Okay, more questions, please. Ben, is this a question?
A general question, yeah. A comment on, feedback I get is difficulty navigating around the text and finding definitions. So I'm just wondering, I think the diagnostic horizons, properties and materials should be taken out of their individual sections and just placed into an alphabetic sequence as per a glossary to cover, because it's navigating between properties, materials and horizons is complicated. I'm just wondering whether anyone else feels the same way. Is that
But this is as it is. We have the chapter on the diagnostics, and then we have the diagnostic horizons in alphabetical order.
Yeah, I know.
Properties
I'm
alphabetic.
saying that, but that's confusing because sometimes you're flicking between horizons and materials, and like it would be more usable, maybe more user-friendly if everything was in an alphabetical sequence, regardless of whether it was a horizon, a material or a property.
Don't know.
Okay. John, okay.
Peter, I don't recall the name of the new horizon, but the materials where it developed churnic properties, but began as maybe a wetland soil. How would a field soil scientist be able to determine that it originated as such a soil?
Yes, so it's difficult. That's why part of the criterion is that you have to know that it was wetland before. I think it's hardly possible to do it when when somebody guides you with eyes closed, and then you must tell whether this is derived from wetland or not. In some cases, you will be able to see it, in others, maybe not. So I added this to the criterion that you must know that. Besides the other criteria, how to recognize how much organic matter, which structure, and so on.
In the moment, I don't see any other questions. So that's time to come to the conclusion. At first, thank you, Pedro, and thank all you for participation and discussion. I think we have had an important lecture now because we hope that we will work with WRB in the future, and we need a classification which really describes almost everything which occurs in soils. But at the same time, it should be simple as possible, and all the definitions should not overlap, so should have clear boundaries, and they should be easily applied, and we should not have too many mistakes in it in the future. So this is still some work to be done, I think, but we are on the right way. That is my impression of today. So let us go on and also help Pedro to make a very good WRB 2022, and then hand over to Cesare to continue make a good work, and also help the people working with WRB. So thank you for this day, and please come back tomorrow morning. We continue.